Summary of the life and career of Julius Robert Oppenheimer, father of the atomic bomb. Chapter 1, Childhood and Education, 1904 to 1927. Julius Robert Oppenheimer was born on April 22, 1904, in New York, growing up in a wealthy but non-observant German Jewish family. His father, Julius Oppenheimer, was a successful textile importer from Hanau, Germany, who started his career from scratch and was one of the earliest importers of art paintings in New York. His mother, Ella Friedman, was a talented painter from an intellectual New York family. She transformed their luxurious home on Riverside Drive into an art space, with paintings by Picasso, Vuillard, Van Gogh, and Cézanne hanging on the walls, a rarity for an American family at the time. From a young age, Robert showed a clear distinction. The boy was passionate about collecting minerals, reading poetry, and pondering deep philosophical questions. At the age of 12, he joined the New York Mineralogical Club and presented his first scientific report on the composition of flint minerals. In 1911, he enrolled in the Ethical Culture School, a progressive school in New York founded by Felix Adler, which emphasized free thought, humanitarianism, and social responsibility. This educational environment nurtured not only his scientific abilities but also his philosophical depth and emotional sensitivity. There, he excelled in science subjects while also studying Latin, ancient Greek, and gradually becoming fascinated with classical literature, especially Greek poetry and Shakespeare. In 1921, Oppenheimer graduated from high school with outstanding achievements but soon after contracted dysentery during a trip to Germany. To recover physically and mentally, his family took him to New Mexico, where the dry air was suitable for treatment. There, he first rode horses through the wilderness of Los Alamos, immersing himself in the vast natural scenery, which left a lifelong impression. New Mexico later became not only a retreat but also the center for atomic bomb research under his leadership. In 1922, he entered Harvard University, where he pursued a rigorous science program, starting with chemistry but quickly switching to physics, the field that captivated him. With his exceptional intelligence, he completed his bachelor's degree in just 3 years, graduating summa cum laude. During his studies, he also participated in literary discussions, passionately reading Keats, Baudelaire, Shakespeare, and Eastern philosophy like the Bhagavad Gita, which he later quoted during the first atomic bomb test. After Harvard, he studied at the University of Cambridge under the guidance of Nobel laureate physicist J.J. Thomson at the Cavendish Laboratory. However, the rigorous experimental environment and the dry personalities there did not suit Oppenheimer's sensitive soul. Feeling isolated, he fell into severe depression and once sent a letter threatening to poison Professor Patrick Blackett, an act that led to him being summoned for questioning and reprimanded. Chapter 2, Educational Journey in Germany, 1926 to 1927. In 1926, Oppenheimer left the University of Cambridge, where he felt lost and stifled by the heavy experimental environment, to go to the University of Göttingen in Germany, the vibrant center of theoretical physics at the time. This was a crucial turning point, transforming him from a talented but insecure student into a scientist with revolutionary contributions. Göttingen, under the leadership of Max Born, one of the main architects of quantum mechanics, was a gathering place for brilliant minds like Werner Heisenberg, Wolfgang Pauli, Paul Dirac, Pascual Jordan, and Enrico Fermi. The academic atmosphere there was like a renaissance of physics, with lively debates and relentless collaboration among young geniuses. At the age of 22, Oppenheimer quickly immersed himself in this intellectual current, not only through his academic abilities but also through his unique intellectual charm. Although somewhat isolated due to his quiet demeanor, he still made a strong impression with his sharp intelligence, quick grasp of theory, and outstanding independent thinking. He worked closely with Max Born, who was developing the mathematical foundations for the newly born quantum mechanics. During this time, the two developed the Born-Oppenheimer approximation, a groundbreaking method in quantum chemistry. This approximation allows for the separation of nuclear and electronic motion in molecules, enabling a more accurate and refined description of molecular structure, something previously impossible with existing mathematical tools. The work was published in 1927 in the journal Annalen der Physik, becoming one of the foundational papers of applied quantum mechanics. This achievement not only solidified his position in the European scientific community but also gained wide recognition in America, where quantum mechanics was still very new at the time. The fact that a young scientist like Oppenheimer, at less than 23 years old, had his name on an important academic work helped him establish himself among giants like Heisenberg and Dirac, quickly becoming a promising figure in global theoretical physics. Beyond academics, his time in Germany was also a period of profound personal growth. He learned German for communication and research, while also immersing himself in classical European culture. He read poetry by Goethe, Schiller, and Rilke in the original, and was captivated by German Romanticism and metaphysical thought. He often took evening walks alone, carrying a book of poetry or handwritten mathematical manuscripts, delving into philosophical reflections on the nature of matter and the meaning of existence, something that later permeated his philosophical lectures. However, this period was not without psychological challenges. Oppenheimer, who always carried a fragile and sensitive nature, still experienced intense inner crises, sometimes due to academic pressure, sometimes due to loneliness and difference. In letters to friends, he occasionally revealed feelings of alienation and anxiety, although outwardly he maintained a calm demeanor. But it was the highly intellectual environment in Göttingen, where debate was seen as a catalyst for progress, that helped him overcome, honing his reasoning skills and providing the confidence necessary for a leading scientist. He participated in specialized seminars, where many big names like Bohr and Einstein gathered, and even engaged in direct dialogue with the minds shaping the future of modern physics. It was in Göttingen that he began to build an international scientific network, a crucial asset when he later became the leader of the Manhattan Project. By 1927, Oppenheimer completed his doctoral thesis under Born's guidance, with a topic on electron theory and multi-electron atomic systems, a complex but promising field. He successfully defended his thesis and simultaneously published several academic articles in prestigious journals. When he left Göttingen, he carried not only a prestigious doctoral degree but also a broad scientific vision, an open mind to knowledge, and a determination to dedicate his life to physics as a lifelong mission. His time in Germany not only shaped Oppenheimer's career but also laid the foundation for a deeply thoughtful scientist, who would later both create great works and deeply ponder their ethical consequences. Chapter 3, Early Academic Career, 1927 to 1942. After completing his doctorate at the University of Göttingen in 1927, Oppenheimer returned to the United States, bringing with him bold scientific ideas and the ambition to make his mark in theoretical physics. Initially, he took a postdoctoral research position at Harvard University and then at Caltech, where he collaborated with Robert Millikan, a Nobel laureate physicist. Although the environment at Caltech was full of potential, he quickly realized that his academic future would be more open at the University of California, Berkeley, a young institution but full of creative opportunities. In 1929, he officially became an assistant professor at both Berkeley and Caltech, splitting his time between teaching and research on both the east and west coasts of America. At Berkeley, he was not just a lecturer but also the one who laid the foundation for the development of theoretical physics in America. He established a strong research group, inspiring a generation of young scientists through challenging and thought-provoking lectures. His students and collaborators, such as Hans Bethe, Willis Lamb, Robert Serber, and Melba Phillips, later became outstanding figures, many of whom won Nobel Prizes. His teaching style was described as intense, scholarly, and sometimes almost like a philosophical discourse, where he combined quantum mechanics, poetry, and philosophical reflection, turning each class into a journey of discovery for both science and the soul. In terms of research, Oppenheimer's notable scientific contributions during this period laid the groundwork for modern physics in America, which had previously lagged behind Europe. He wrote dozens of papers on quantum mechanics, atomic physics, and nuclear physics, including pioneering works. In 1935, with Melba Phillips, he developed the Oppenheimer-Phillips process, a model explaining how nuclear reactions occur when light particles like deuterons collide with heavy nuclei, a crucial mechanism for understanding stellar energy. In 1939, along with George Volkoff and student Hartland Snyder, he pioneered the prediction of neutron stars and the first mathematical description of black holes, known as the Oppenheimer-Snyder solution, one of the earliest theories of gravitational collapse. Although the concept of black holes was not yet popular, his work opened a new chapter for astrophysics and cosmology. Besides science, Oppenheimer also showed a multidimensional soul through his passion for literature, philosophy, and Eastern culture. He learned Sanskrit to read the Bhagavad Gita in the original, often quoting ancient Indian poetry in academic conversations. He admired poets like T.S. Eliot and John Donne, and loved Western metaphysics. His discussions were not only about the Schrödinger equation but also about Nietzsche, Shakespeare, and meditation. This made him stand out in academia, a physicist with an artist's soul and rare philosophical depth. In the 1930s, Oppenheimer was deeply influenced by global political events, especially the rise of fascism in Europe. In 1934, he helped Jewish scientists fleeing Nazi Germany, including donating money to support their families settling in America. By 1936, he supported the Republican side in the Spanish Civil War, participating in fundraising events and having close ties with left-wing intellectuals at Berkeley, including members of the American Communist Party. Although he never officially joined the party, Oppenheimer admitted to supporting many of their activities and ideals. In 1939, when World War II broke out, he joined the American Committee for Intellectual Freedom, an organization linked to the Communist Party. These relationships later became the reason for his investigation by the FBI and tarnished his reputation after the war. In his personal life, in 1940, he married Catherine "Kitty" Puning, a biologist who was once a member of the Communist Party and the widow of a fighter in the Spanish Civil War. They had 2 children, Peter born in 1941 and Tony born in 1944. His complicated relationship with Jean Tatlock, a psychiatrist and writer who was also a Communist Party member, continued in parallel for a while, leaving a deep mark on his life and later security files. This period was an intersection between scientific genius and conflicting personal choices. Oppenheimer became the embodiment of complexity in modern intellect, a person who both created theories that changed our understanding of the universe and was swept up in the whirlwind of politics, ideals, and inner conflicts. All of this prepared him for a fateful period, where science, power, and ethics would collide fiercely in the coming brutal war years. Chapter 4, The Manhattan Project, 1942 to 1945. In 1942, as World War II reached its most intense phase and the risk of Nazi Germany developing an atomic bomb became increasingly apparent, Oppenheimer was invited to join a top-secret project of the U.S. government, the Manhattan Project. This was the largest research and development program for nuclear weapons in history at the time, funded by the War Department with the collaboration of many universities, laboratories, and leading scientists. Despite lacking management experience and being suspected due to his ties with left-wing groups, Oppenheimer still impressed with his strategic organizational thinking and comprehensive understanding of both theoretical physics and nuclear engineering. In 1943, he was chosen by Lieutenant General Leslie Groves, the direct overseer of the Manhattan Project, to be the scientific director of the Los Alamos laboratory in New Mexico. This choice was controversial in political and military circles, but Groves had absolute trust in Oppenheimer's abilities, describing him as the only one who could connect the talented scientists together and keep them on track. Oppenheimer himself proposed the geographical location of Los Alamos, where he had youthful memories, as an ideal site, isolated, secure, and inspiring. Oppenheimer quickly transformed the New Mexico desert into a large-scale nuclear research center. He reorganized the laboratory structure, dividing it into specialized groups such as the Theory Group, Weapon Design Group, Testing Group, etc., each led by top scientists like Hans Bethe, Edward Teller, Enrico Fermi, Robert Serber, and Klaus Fuchs. By 1945, Los Alamos had gathered over 6,000 personnel, from renowned scientists to engineers, technicians, and support staff, all working under strict security and intense time pressure. Under Oppenheimer's direction, this team had to solve a series of technical challenges: purifying uranium-235, producing plutonium-239 from nuclear reactors, and especially designing the fission detonation mechanism, a complex problem with no precedent. Throughout this time, Oppenheimer demonstrated outstanding leadership. He was not only professionally competent but also knew how to inspire team spirit, handle conflicts between research groups, and motivate with intelligence, integrity, and a shared aspiration. On July 16, 1945, in the Jornada del Muerto desert of New Mexico, the Trinity test, the first atomic bomb explosion in human history, took place successfully. This was the result of 3 years of intense intellectual and technical labor. Witnessing the blinding light and the giant mushroom cloud rising into the sky, Oppenheimer solemnly quoted a line from the Bhagavad Gita, "Now I am become death, the destroyer of worlds." This statement not only reflected his profound knowledge of Eastern culture but also expressed the deep ethical concern silently rising within him. Just a few weeks later, on August 6 and 9, 1945, 2 atomic bombs codenamed Little Boy, using uranium, and Fat Man, using plutonium, were dropped on Hiroshima and Nagasaki, respectively, causing unprecedented destruction and forcing Japan to surrender, ending World War II. The success of the Manhattan Project earned Oppenheimer the title, Father of the Atomic Bomb, occupied, and he was awarded the Medal of Merit by President Truman in 1946, one of the nation's highest honors. However, behind the glory were deep ethical concerns. Oppenheimer began to doubt his role in developing weapons of mass destruction. In a private meeting with President Truman in October 1945, he blurted out, "I feel like my hands are stained with blood." This statement angered Truman to the point that he later told his aide, "Never let that man come back here again." This period not only marked the pinnacle of Oppenheimer's scientific career but also opened a new chapter full of inner conflict. From a theorist passionate about exploring the microstructure of the world, he had become a contributor to the nuclear age, an era in which humanity holds the power to destroy itself. The tension between creative genius and moral conscience began to haunt him for the rest of his life, turning him into a complex symbol in modern history, both a creator and a witness, questioning the cost of progress. Chapter 5, Post-War Leadership and Controversy, 1945 to 1954. After World War II, Oppenheimer was not only a scientific icon but also became a highly influential figure in U.S. nuclear policy and strategic thinking during the early Cold War period. In 1947, he was appointed director of the Institute for Advanced Study in Princeton, a place that gathered the world's leading minds like Albert Einstein, Kurt Gödel, and Freeman Dyson. There, he not only oversaw research activities but also shaped the intellectual direction for the post-war generation of scholars, building a free and interdisciplinary academic environment where physicists, mathematicians, and philosophers together sought fundamental knowledge about the universe and humanity. Simultaneously, Oppenheimer served as chairman of the General Advisory Committee of the U.S. Atomic Energy Commission, AEC. In this role, he was central to shaping post-war nuclear policy. In 1946, he made significant contributions to the Acheson-Lilienthal Report, a groundbreaking plan proposing international control over nuclear energy and preventing the proliferation of atomic weapons through centralized management of reactors and nuclear materials worldwide. Although this proposal was rejected by the Soviet Union and did not materialize, it demonstrated Oppenheimer's strategic vision and humanitarian spirit. However, as the Cold War escalated and the Soviet Union successfully tested an atomic bomb in 1949, a wave of security concerns spread among American politicians. In this context, Oppenheimer firmly opposed the development of the hydrogen bomb, H-bomb, a weapon hundreds of times more destructive than the atomic bomb. He believed that pursuing the H-bomb was not only unethical but would also lead to an uncontrollable arms race, threatening global security. This stance put him in sharp conflict with Edward Teller, who advocated for the H-bomb's development, and especially with Lewis Strauss, an ambitious AEC official who later played a key role in Oppenheimer's downfall. Political tensions rose, and Oppenheimer's career took a turn in 1954 when he was summoned to a security hearing, a highly politicized event. Under pressure from the Eisenhower administration and Strauss's influence, the Atomic Energy Commission decided to reinvestigate Oppenheimer's security clearance, citing his past associations with the Communist Party, particularly his relationship with Jean Tatlock, activities from the 1930s, and colleagues with leftist views. The 3-week hearing was not a public trial but an internal procedure full of injustice. Oppenheimer was not allowed to cross-examine key witnesses, many audio recordings were edited or kept secret, and the questions focused more on character flaws than specific actions. Although he was not accused of treason, the committee concluded that he was a national security risk, leading to the revocation of his security clearance and his removal from national nuclear programs. The hearing, later widely publicized, became a stain on U.S. political and scientific history, outraging many scientists and intellectuals both domestically and internationally. Einstein, Dyson, Bethe, and many other prominent figures publicly protested the treatment of Oppenheimer. This decision ended his role in public policy but could not erase his academic and spiritual influence in the scientific community. Oppenheimer returned to Princeton, continuing to teach and write. His lectures during this period were deeply philosophical and introspective, often addressing the relationship between science, ethics, and power. He appeared at international conferences, where he was still respected as a symbol of intelligence and integrity. In the late 1950s, he sought peace at his home in St. John, Virgin Islands, where he and his wife Kitty had bought land since 1957. There, he often let his mind drift on boat trips, wrote, and reflected on his journey. Works like The Open Mind, 1955, are profound reflections on the role of knowledge in modern society. It was not until 2022 that U.S. Secretary of Energy Jennifer Granholm officially annulled the old decision, stating that the process against Oppenheimer was unfair, biased, and erroneous. Restoring his honor was not just a symbolic act but also a belated apology from America to a man who had dedicated both his intellect and soul to the country. This period is a profound testament to the fragility of reputation, the power of politics, and the high price that an intellectual daring to live with conscience must pay. The controversies did not overshadow Oppenheimer's talent and stature. On the contrary, they highlighted the complexity and depth of a man standing at the boundary between science and ethics, leaving a haunting lesson about responsibility, freedom of thought, and the cost of speaking the truth in a turbulent era.